All right, this is another opportunity for you to do the math, okay? So we're gonna start the next example by you pausing the video and trying to do A, B, C, and D. And again, the graph is on the next page for what A, B, C, and D want you to do. Okay, so go to the next page. Try to do A, B, C, and D on your own. Do your best, and then we'll see together what the answers should look like. So pause the video now. All right, so we're going to start by drawing the secant line between the point 1, 2 and 2, negative 1. 1, 2 is right here. 2, negative 1 is right here. We need to draw the secant line between these 2 points. So should get it like this. And now we need to find the slope. So this red slope, well, that's just going to be the change in y. So y2, right? This is the point negative 1. Sorry, no, it's not. It's the point 2 comma negative 1. This is the point 1 comma 2. So the slope is y2 minus y1 over x2 minus x1, negative 3. The slope of this red line is negative 3. Great. So that is a secant line. That is that slope of a secant line. Hopefully you got that. Letter B, oh, I can even label this. Letter B wants us to do the same thing, but now don't go as far. Same starting point, but now go to the point 1.5 comma 1. We can do that in blue. So same starting point, but now 1.5 comma 1. We need to find this slope now. And we need to draw this line, so we'll go and do the same thing. Like so. And if I'm really good, I should be including arrows on this. So the slope is y2 minus y1 over x2 minus x1. That's negative 1 over 1/2. It goes to negative 2. That's part B. Now, part C is interesting. Part C says, not saying that letters A and B weren't interesting, mind you. Draw the secant line between the same original starting point and now 1 plus h, comma, f of 1 plus h. So here I want you to imagine that h is a very small number. So maybe we're adding 0.1. And then that if h were 0.1, right? If h were 0.1, then we'd have the point 1.1, f of 1.1, right? If h is some small number, and h can be as small as we want. H could be 0.01 or something like that. We're doing it in generality for a small value of h. So we'll draw a little picture and say we have the same starting point. But now let's say that we're only moving a little bit. So now our x here is 1 plus some small number, and the y is the function value at that 1 plus small number. Well, now what our tangent line will look like is something like this. Right? Sorry, what our secant line will look like is like this. And notice that all of these secant lines are getting closer and closer to this idea of some tangent line. The closer your points get together, the closer you get to approximating the tangent line, which we haven't talked about finding yet, because that's in a future section, okay? Well, now what does the slope look like for this green guy? Well, now it's a little bit more complicated, okay? So now what we do, right, our slope is going to be the second y, which is some function value at 1 plus h, minus the first y, which is 2, over the second x, which is 1 plus h, minus the first x, which is 1. We don't know what this function is right here, so we can't simplify the numerator. But we can simplify the denominator, right? If we add 1 and subtract 1, those cancel out. Now, if this were a function that we knew, we could keep on simplifying, and you'll have some of those in your homework assignment. But for us, that's as much as we know about the slope here. All right. This is how we can find slopes of secant lines. If they have specific points, it's pretty easy. But we can also find it in generality if h is just some small number. And that'll be very useful when we introduce this idea of a limit, which is in the future. All right, letter D says, draw your best guess for the tangent line. What do you think its slope is? I probably should have given you another picture because we're really just writing on top of ourselves now. But the idea is that the tangent line should be, I don't know, something that kind of like bounces off the function here. Kind of hard to draw it here. This is the idea. All right. I'm like bouncing off the function here. There's not really room. You don't have to draw letter D. What do you think the slope is? I don't know. Something kind of small. Something negative, for sure. So we'll just kind of answer that for letter D. We don't know yet. Something small. Negative. We'd expect blue to be a better approximation than red. And maybe we think it's going to keep going the same direction. Maybe we think our slope is -1. That could be a good guess. Red was inaccurate. Blue was a little bit more accurate, but blue is still not very accurate. We'd have to go a little bit further. Maybe -1. I don't know. If we had a cleaner picture, we could draw it and approximate it that way. But that's not the point here. The point is, what's the connection between a secant line and a tangent line? What is a secant line? What is a tangent line? More about tangent lines right now, okay? So let's say we have another graph, some function g of x. It's this red squiggly doodah. So how could we draw the tangent line where x equals 1? So x equals 1 is right here. The tangent line is the line that kind of bounces right off of it. So here, the tangent line could be like, I don't know, maybe it's this. Maybe it's a little higher than that. I don't like that. That could be the tangent line here. Notice that it like skips off of the graph. Talk more about how to find tangent lines and what they look like later. So if this is still a little unfamiliar, don't worry too much. Okay. And then letter B says draw the tangent line when x equals 0. When x equals 0, that's like right here. So the tangent line, and again, if you're ever uncertain, you can think of the tangent line as the secant line if you have 2 points really close to each other. What would the line look like if we connected these really two close points together? It would look kind of like that. All right, and that's all you have to do. Now let's look at letter C. At what values of x do you think the graph has a horizontal tangent line? Well, we already know 1, because look, there's a horizontal tangent line. The tangent line, this black line, is horizontal at x equals 1. So we already know that's one of our options. Where else do you think it's going to be horizontal? What's special about x equals 1? Well, x equals 1 is the top of a hill. So it follows that we might have a horizontal tangent line right here too. It's also the top of a hill. All right, if we drew a tangent line here, we're going to get something very similar. Okay. And again, you can think about this tangent line as just draw 2 points really close to each other. How do they connect? Well, it looks pretty horizontal. All right. So we think there's also going to be one when x is 5. Where else? Well, the top of the hill, but probably also the bottom, right? The valley, the bottom of the valley at -1, and maybe about 2.5 as well. So in general, we'll talk about this later, that if we have a continuous function with certain things about derivatives, that we'll have horizontal tangent lines at the top of hills, the bottom of valleys, and so on. Okay? Great. Well, last thing, make a note. Let's make a note to ourselves. Top of hills, bottom of valleys. What are a few values of x where you think the graph has a positive slope tangent line, a tangent line that's going up? Well, we have one example, right? This blue line at x equals 0, we know that the tangent line is increasing. Why is it increasing? Because as we look along this blue line from left to right, we're going uphill. Always from left to right here. What about over here? Well, this tangent line would look something like this. That'd be downhill from left to right, so this couldn't be it. What are some other points? Well, anytime that the red graph is going up, anytime that the red graph is going up from left to right, we'll have an option. So actually, any point between -1 and 1 would be a good choice. Any point between 2.5 and 5 will be a good choice. The function is going to be increasing there. You can choose whatever ones you want. So we could say, -0.5 would be one. The function will be increasing right here. We could say 4, we could say 3. The function is going to have increasing tangent lines at all these places. There's infinitely many. And what we'll look for, it has an increasing tangent line where the red graph is going up from left to right. And that'll be a big theorem that we'll talk about later in this chapter too. Later in this chapter 2, or later in this chapter 2, how clever. How very funny. Nice job, Jason. You did good. All right. So that's it for this video. That's it for the new material. I've got a cough again. I'm sorry. We'll do some homework problems in the next video for extra practice.